So I'm Michelle Leishman. I'm a plant ecologist, as Anna introduced me. I'm the director of two centres at Macquarie Uni. One is Smart Green Cities, which has been going for a number of years now. The other is the Australian Harmony Centre for Ecosystem Futures, which is a new centre which focuses on nature positive, nature repair and the circular bioeconomy. And both of them bring together academics, researchers, industry, government and so on, but across disciplines. So they're multidisciplinary centres, and I guess that's kind of aligns with what Anna was talking about, the concept of those three organisations that are running this today. It's about bringing people together in partnerships to solve the big global challenges. So my interest in particular is in urban green space and the urban forest, and I'll talk mostly about that and about nature-based solutions and how we can use those in cities. So the world is becoming increasingly urbanised. We live in a very highly urbanised planet. 60% of the global population lives in a city. By 2050, when the population is expected to be nearly 10 billion people, 2 out of 3 people on the planet will live in an urban area. So urban areas are incredibly important. And even in Australia, we don't think of ourselves as being an urbanised population. People think Australia is the great outback and so on, but actually 86% of us live in the city, which is an astonishing number. So the thing about cities is that they punch well above their weight in terms of resource use. So they take up a very small proportion of the land area, less than 2%, but they account for nearly 80% of global energy use, about 60% of our global greenhouse gas emissions, and about 70% of global waste. So what we do in our cities really, really matters. They're often referred to as the kind of engine room of the economy, but they're more than that, right? They're not only the engine room, it's where people live, and they're a considerable impact on our environment, even though they're small. But they face these enormous challenges. So we have, our cities are congested, we have problems with air pollution, we have problems with urban heat, we have problems with, increasingly with climate change, so flooding, bushfires, extreme heat and so on. And those things are only predicted to get worse with climate change. And it turns out that cities are not particularly good for our health in particular, and a lot of that is to do, we've known for a long time, is to do with air pollution, but we're increasingly understanding that it's more than that. It's about the urban biome, our own microbiome, it's all sorts of different things about exposure to sunlight, and in particular mental health. So we've kind of worked out in COVID how important it was to be able to get out into our urban green spaces, that is becoming increasingly apparent about the link between access to nature and people's mental health and well-being. And I'm an ecologist. I'm interested in plant conservation and conservation biology, and in particular in biodiversity in urban environments. And cities are pretty rubbish places for much of our wildlife and our wild plants. So a city like this doesn't support much biodiversity. And when we look forward and we see how global cities are expected to expand with urbanisation, increasing urbanisation, we see that many of the global hotspots will be impacted, global biodiversity hotspots will be impacted by increased urbanisation. And even in Sydney, of course, we're pretty familiar with this, aren't we, as we see greenfield development impinging on our wildlife and our green areas. Rural koalas are often in the media, of course. So, not surprisingly, what we're seeing is this kind of shift in interest towards how can we use nature and how can we use nature-based solutions to overcome some of these big problems that we have in our cities. So how can we use nature-based solutions to enable mitigation and adaptation to climate change, to support people and to support biodiversity. So I'm going to talk about this in the rest of this talk, just how we're using some of these nature-based solutions to facilitate nature-smart, livable cities. So this is an image that comes from a business magazine. I just found this on the web one day when I was cruising around, and I use this because it's not from an environmental publication, it's from a business standard. So this is now becoming this kind of, people, this is mainstream now. People understand that urban green space is important, and it has all of these different features that help us. We can use green space for nature-based solutions, and they include things like managing our stormwater, managing our waterway pollution, reducing urban flooding. We can use nature-based solutions for extreme heat, so managing extreme heat, providing cooling, reducing our air pollution problems, so filtering our air and increasing air quality, but also, of course, protecting biodiversity, but also in particular people's health. So there's lots and lots of data coming out now about the proximity to urban green space, access to urban green space, and how that is related to all sorts of things: diabetes, cardio problems, anxiety and depression, asthma, and so on. And finally, of course, cities loves this stuff. Actually, access to green space and proximity to green space increases property values. So it's a win-win situation for more green space that we have. And in Sydney, we're incredibly lucky. We have remnant vegetation surrounding the city, but also embedded within the city, places like Lang Cove National Park, Georges River, and so on. So we're incredibly lucky that we have natural remnant vegetation. But we also have all of this other stuff, which we call urban forest. This is our urban green space. We have street trees, we have parks and gardens, we have residential gardens, so our home gardens matter as well. We have rain gardens, we have increasingly new places like green roofs and green walls, even our golf courses. Green space is all of these things, and it can all contribute to these nature-based solutions to these urban challenges. My interest is particular in biodiversity. These are some of the species that we live with in Sydney. Some people love some of these species more than others. Chickens, for example, are not always loved. Brush turkeys are not always loved. Personally, I love brush turkeys. I think they are the most persistent, unbelievably, amazing animals. But we have endangered species like powerful owls, we have green and golden bell frogs, we have long-nosed bandicoots, bats, a whole range of different things living amongst us within our cities. And that's incredibly important that we recognise this and that we help to facilitate all of this biodiversity. And many people don't know that there's a large number of threatened species in our cities. So 30% of the species that are listed as threatened under the EPBC Act occur in cities. So what we're seeing now is all of these sorts of publications coming out from government. So there is things, so the one in the middle, Net Biodiversity in Place, that comes from the New South Wales Government Architect. There's stuff from the Green Building Council. There is stuff produced by academics and councils. All of these things are to do with increasingly understanding how we can have biodiversity sensitive urban design, how we can have all sorts of things, pollinator habitats, woody meadows. There are a whole range of different things that we are now seeing increasing interest in, and how we can actually put them in place in order to provide these nature-based solutions. But these are our problems. This is one of our problems. Our cities are changing. Already our cities are hot because of the urban heat island effect that we're all pretty familiar with, but also because of climate change. So the figure on the left is the temperature anomaly. Our temperature has increased over 1.5 degrees in Australia since our records began in 1910. The picture on the right-hand side is rainfall, and so this is rainfall periods. You can see that our continent is drying, particularly in the southeast and the southwest, which of course is where all of our cities are. So we have problems with climate change that we need to be able to adapt to. And part of climate change in particular is this extreme weather condition. So we can shift the mean temperature up a little bit, like the picture on the top left, but a small shift in the mean, like that 1.5 degrees, actually results in significant increases in extreme events. In this case, record hot weather. What do we have in Sydney the other day? I think Wednesday, 38 degrees in October. So we're seeing our heat records being smashed. And in cities in particular, we're seeing our heat waves happening earlier, lasting longer, being hotter, and so on. A whole lot of stats there around Australia's cities. And of course, in Western Sydney, we see this is the focus for many of our councils, is the extreme heat that we have in Western Sydney, because they're not subject to that the sea breeze that we get in the east. And so we can look at health figures, and heat-related mortality can be up to 3 times higher in Western Sydney than it is in Eastern Sydney during those heat waves. heatwave periods. So when we're building things like this is a greenfield development in Western Sydney with no space for green, no space for trees, we're setting ourselves up for disaster in the long term under climate change. So we've been using really very straightforward stuff for a number of years now to show the impact of green spaces. So the picture on the left is an area within Parramatta, local government area, and on the right hand side is the same area, but this is a thermal image, the heat map from Parramatta. It's pretty easy. You can look from one image to the other. You can see where the green spaces are. On the left hand image is where the cooler spaces are when we use thermal imagery. Very simple. This has been the sort of thing we've been using for years to show how we can target areas for green space development. But we're getting more and more sophisticated. So this is the sort of aerial imagery and data that we can use now. This is from the New South Wales Government's tree canopy data. So they've done 2 runs of this now, 2022 and 2024. There's one more scheduled, and hopefully this will continue on because we need this kind of long-term data sets. So they're looking at flying aircraft over. They use image analysis and LiDAR and so on to collect data on where the trees are, or where the canopy is, to quantify that, to look also at the heat, to map that together, and then to put that together with socioeconomic data, so demographic data and so on. And then they can do things like build those heat vulnerability maps to show where are the more vulnerable populations, where are the opportunities to put green space, and how can we increase our canopy. And so it's this kind of use of big data and technology which is really helping us in our urban planning. Lots of councils are interested in managing heat. This is the focus for many councils, particularly in the West. How do we get our schools to be cool? This is a project that I was involved with, the school microclimates. How can we have cooling strategies at the local level and greener streetscapes and so on is a major part of that. But it's not just about cooling. Urban forest strategies, when I started off in this 15 years ago, nobody had an urban forest strategy except for the very big councils. Now most of our councils will have an urban forest strategy. And that includes that they're collecting data on every single tree, mapping the canopy, understanding where the opportunities are, all sorts of things going on. But it's really important that we look to the future and understand how climate change will impact that urban forest and what can we do to increase the resilience of that urban forest. And this is happening globally. There's a bunch of examples there from Sydney and across Australia, but there's one from London, this one in Singapore. The 330-300 rule is the big thing in Europe at the moment, which is that all people should be able to see 3 trees from their house, be within 30 metres of green space, and there should be 30% canopy. That's the kind of rules that we're heading towards. In New South Wales, we have urban green targets. We have the 5 Million Trees program. We have the Greener Places framework. Adelaide's got similar things. All of our cities are working towards these kind of big urban forest strategies. But this is our problems. We know that urban green space is important. We understand the importance and how we can make them resilient. But this is the sort of challenges that urban green space has. Increasing urbanisation, conflict with infrastructure, whether it's overhead wires, and we see this hideous transformation of our trees, pavements, utilities, root chokes, and so on. And it's not just greenfield development, but also urban expansion. So the picture on the left, the 2 pictures are the same place, but different times. So when I grew up, I lived in an urban suburban block like that. We had, a modest, relatively modest 3-bedroom house with a big backyard and lots of trees. Now our houses are much bigger. They've got pools, they've got much more concrete, there's no room for trees, no room for green space. And as the climate's heating up, many of our trees are feeling the heat. These are some pictures from Western Sydney after a long hot summer. These were taken a few years ago. But things like plane trees have scorched like this. This is a native species. This is Banksia Sharada, old man Banksia. Tough as anything, but really not able to cope with these very hot temperatures when they're set within the streetscape. And because this is what happens, plants can't cope with these high temperatures, and particularly unless they have their roots in very good access to soil water. So they cool themselves by pumping up water, transpiration. That's their air conditioning system. If it's dry, they can't do that very well. So we can use thermal imaging and we can look at temperatures of leaves. So this was taken when the air temperature was 40 to 40.7 degrees, but you can see that the leaf temperatures are over 50 degrees. So the plant's not got enough access to water to be able to cool itself, and that's when we get these leaf scorch patterns. Now some of you might remember that we had that incredibly hot day in January 2020. So we had that long period of dry, no rainfall. You can see in the graph on the bottom, and then these are the temperatures here in Western Sydney. You can see the red spots are when they're over 40 degrees. So on the 4th of January, remember it was 48.9 degrees. Penrith was the hottest place on the planet at that time. Unbelievable. And so we wanted to see, it's like a natural experiment, we wanted to see, well, how are all of our plants coping when we hit them with that drought and then hit them with these extreme weather conditions. So we did some canopy assessments, and so like I said, all of these councils are building their tree inventories and digitising them. So we actually had digital maps of Penrith, so we knew every single tree where they were, and we could drive around in our car in air conditioning, which is a very good idea when you're in the middle of a heat wave, and visually assess all of the street trees. So we looked at more than 5,000 of them over nearly 100 k's of road and assessed them for the amount of foliage damage that they had. And so this is just the top 20 or so trees, and the ones that had the most damage were the exotic deciduous species. Native species coped much better than the exotics with these very extreme temperatures. But almost 10% of street trees experienced some level of canopy damage. So our native trees did much better, but many of our street trees were damaged. And you can calculate how much that costs the economy, right? So we did the calculations of if we replaced them, and we did two different scenarios, if we just used juvenile trees or if we used adult trees. And the calculations were $584,751 if you use the smaller trees, and over $800,000 if you use more advanced trees. That's a lot of money. That's one extreme climate event in one council area, and it was only a part of that council area. So this is going to be a significant cost for the economy as we go forward with climate change. So that's what's happening now. We can look into the future. We can do bioclimatic modelling. This is something that many of us do in universities, where we have this sort of access to this large spatial data. We have access to the climate data. We have access to what will climate projections. And we can put all of this together. We build what we call a climatic envelope for individual species. And we can see how individual species will cope in the long run. This is some work we did a couple of years ago. We did this for 176 native species that are planted in urban environments across Australia. And we showed that a very large proportion, nearly 75% of them, there would be a decline in the area of climatic suitability for them by 2070. So the sorts of trees that we're planting now will not be doing so well into the future. So what that means then is that we need to think about the species that we put in the ground for our urban green spaces. We need to think about, as we're doing our plantings, are we going to put plants in the ground, species in the ground that will cope in the future? We need to have species that have capacity to cope with low water availability, with these extreme temperatures, but also the tolerance of new pests and pathogens that are arriving with climate change. So already we're seeing tree canopy in Perth being decimated because of a new pest, which is the polyphagous shock hole borer, which has come in with international trade. We can do the scanning. We need to know what species, what pests and pathogens are coming in the future so that we can protect our forests. We also need to increase our diversity. So we have, if we put all our eggs in one basket, if we have a very low diversity, then when we get those pests and pathogens, it's much more a problem than if we have a lot of diversity in our street trees. So we know that we need to do these things. Councils know that they need to do these things. Property developers, landscape architects and so on, all people who are putting greenfield, urban green space together, managing our green space, understand this. But when we started on these projects a few years ago, they didn't have the tools and resources that they needed to make good choices about species selection. The data and the evidence just wasn't there. So we built a tool. This is the Witch Map Ware tool. We built a data set of nearly 3,000 species And we put together all the information about their traits, how fast they grow, what they look like, what sort of areas they're suitable for, and we did all of that bioclimatic modelling so that we know what areas are going to be suitable for them into the future. So that was a very big data exercise. We put some of the species through their paces in the glasshouse, so we grew them. We have very good plant growth facilities at Macquarie Uni. We grew them under heat and drought and assessed them visually, but did a whole lot of physiological measurements too, so that we understood which plant species can cope with heat and drought. And then we pulled together a whole lot of resources that would help urban planners who are working in greening. So how to do street tree trials, how to establish trees, how to build a tree inventory, all of those sorts of things, sort of basic resources. And we put them together into an online tool. So this is a free online tool, anyone can go on. We have over 4,000 subscribers now. And it's about future-proofing the urban landscape. So how the tool works is that you can search either for by location, and it works at the postcode level, so you can put your postcode in and it will give you a list of species that are climatically suitable for that postcode under current climate, which is 2030, under future climate 2050 or 2070. So you can search by postcode, you could search by species. You might just have a favourite species that you want to look up and you want to see whether it's going to be okay in your area into the future. And you can also filter. So if you were doing a search by postcode, you might only be interested in trees, or you might only be interested in trees that are less than 15 metres in height because you've planted them under the power lines, or you might care about shade tolerance and so on. So there's a whole series of filters as well that you can use. And then it will give you this traffic light summary. So for each species, there's the green is it's going to be okay in those time periods, the yellow is it's a bit marginal, and then some of them get a red traffic light to say, no, do not plant that, it won't be suitable in that time period. It's got a whole lot of maps, climate suitability maps, for those who care about maps and the detail and want more information than just that traffic light type of approach. And the other thing that it does is that it talks about co-benefits. So if you are a landscape architect or you work in council and you were planning a development and the green space of that development, you might choose your species using the tool and then say, okay, species A, I'm going to have 15 of them, species B, I'm going to plant 20 of them, and then it will calculate for you the total canopy area that you'll have when the trees are established. It will calculate for you all the co-benefits, so it will tell you about the diversity of the trees that you've put in there. It will tell you about the biodiversity value, it will tell you about the carbon value, and it will tell you about the shade value. So it will help you to put your planting palette together to make sure that you've got the right sort of co-benefits that you desire. So this is it. You can have a look, you can subscribe, it's free, and all of those tools and all of the science that underlies it is all available for people to have a look at. The other sorts of things that we need for our urban green space to make sure that it's resilient is to actually test things. So we have experimental arboretum around in different places. These are a couple that are out at Mount Annan, where we are planting species that are commonly used, but we're planting different provenances. So we're planting the local ones, and then we're planting the same species, but that come from hotter and drier areas. And we'll follow them for years and see if using hotter and drier provenances is more successful than the local ones. We have arboretums set up like this with a whole lot of very clever sensing infrastructure there. We know what is going on with the soil water, we know what's going on with the climate, we're watching tree growth, and we're also, this is one with Sydney Water where we're using recycled water. So it's very clear that as we develop further in Western Sydney, that we will not be pumping wastewater out to sea, out to Malabar. We've all seen what the problems are with that. Instead, it's about keeping the water in the landscape. So how can we use our recycled water? Is it okay to put recycled water to make our green spaces functional? Because when we add recycled water with a different chemistry, how will that change the chemistry of the soil? How will that impact plant growth? So, talked a lot about greening in terms of cooling, but bringing it back to biodiversity. So we want our green spaces to be resilient, to provide those services in terms of stormwater, in terms of cooling, but we also want them to provide a home for our biodiversity. Here are some of the examples of the sorts of publications that are now coming out. Biodiversity in Place from the New South Wales Government Architect Committee for Sydney produced a Nature Positive Sydney a couple of years ago. The other one was from the Green Building Council. There's these sorts of things out there now. So they provide guidance, but we need more and more evidence about how things work for wildlife. This is some of the other research that we do at Macquarie. This is one of my colleagues. And so she works on understanding how wildlife use the green space in our cities. And she uses all sorts of very funky infrastructure. So we have motion triggered cameras set up in different areas around the city. We have acoustic monitors, so she can hear bat species, she can hear bird species, in particular bats she's interested in. So even in our campus at Macquarie Uni, we now know that we have 6 species of microbats that use the campus every night, come through along the creek line and then disperse across the city. So we use all sorts of different monitoring techniques. We use testing whether the bat roosts work, looking at the temperature and the humidity with them, and whether the animals use them and they work. So lots of interesting things about understanding how wildlife use our cities. This is another researcher at Macquarie. She also uses lots of very funky material. She looks at, she uses what we call terrestrial laser scanning, which basically builds a 3D picture of the habitat so that we can understand the complexity of the habitat, which animals use it. You know, does it matter whether we have a shrub layer? Does it matter what that shrub layer looks like? Does it matter about the relationship of plants together where they are spaced and how to impact how animals use them and animal behaviour? So we, again, camera traps, ecoacoustics and so on, and we can map areas. This is the Leishman Valley. We can map the valley and understand how animals use it. We also do a lot of work on thinking about how our cities, how we can repair our cities in terms of restoration and how we can provide new habitat for them. So it might be woody meadows, like the picture on the bottom left, bat roosts. The one in the middle is the frog saunas. I'm not sure if you've seen any media about the frog saunas, but many of our frog species are very impacted by chytrid virus. And this is some work about we build into our built environment areas where our frog species can go that are warmer. So these are just simple bricks. When they're warmer, they are less vulnerable to the virus. And that's incredibly important. Just little simple things that we can do around our environment to help native wildlife. Habitat pods providing an area where animals can go close by when they're so exposed to predators. So these are new habitat pods. The living seawalls, again, if you've been around the harbour, you might have seen living seawalls. And we also do cultural burning, bringing people back on country. This is a cultural burn that took place in the Leishman Valley, the first time the cultural burn had been done since colonisation. So bringing people back onto country in the city and Indigenous, in partnership with our Indigenous communities. So I will finish up there. Just the last thing. This is a Smart Green Cities Research Centre in the Australian Harmony Centre. You can hop online, you can see some of the sorts of projects that we do, and we're really interested in working in partnership with people to bring knowledge together across different disciplines to how we can make our cities to provide all of those services that we need to work in partnership so that our cities are livable, beautiful places to be. Okay, thank you very much.